All right, so looking at the polar form of a complex number, we can actually switch between polar, complex, and rectangular. We just need a little bit of information to be able to do that. So first of all, let's talk about complex numbers just as a reminder. So a complex number is written as z equals a plus bi, where a is the real part, b is the imaginary part. So a is represented along the x-axis and b is represented on the vertical axis or the y-axis. So if we have an equation in polar form like z equals 4 plus 3i, and we draw that picture with a triangle, so I'm going to go over 4 and up 3. I know the hypotenuse, and actually, let me go ahead and leave this in complex form. I know that the absolute value of z, which is the modulus, is 4 squared plus 3 squared. And so that means z, the modulus, is 16 plus 9, or the square root of 25, right? When I find the modulus, it's c squared equals a squared plus b squared, basically the distance formula. So I know that the modulus, or z, is 5. Okay, when we talk about polar form is written like z equals r cosine theta plus I sine theta. So this is polar form, all right? So when I write something in polar form, I need an angle and I need the radius, right? So to get the radius, I've already done that with z. So I have 5. And then to get the angle theta, there's a couple of ways I can do that. I can do tangent inverse. I can also do cosine inverse or sine inverse, but usually we do tangent inverse because those are the values we're given originally. And if there's a mistake finding the radius, finding r, then we don't have to worry about it. All right, so I do tangent inverse and I get that angle theta, and I replace this angle theta with it. Okay, so whatever that is, cosine of whatever that angle is, plus I sine whatever that angle is. And a lot of times it will be a special triangle instead of just random. Although when you look at complex numbers switching to polar form, you'll see that quite a bit. All right, let's go the other way with it. Oh, by the way, they will abbreviate this. Sometimes you'll see it. I just want you to see this as, if my pen will write, CIS. That means, RCIS. So they'll abbreviate this inside part as CIS, which means cosine theta plus I sine theta. All right, so I'm going to do the abbreviation. Let's change. All right, let's graph this, and then I'm going to put a 2 in the front. And then let's see if we can switch it around to different forms. All right, so this really means 2 cosine of pi over 4 plus I sine pi over 4. So the information they gave me is the modulus, so that's the radius of my circle, and then they also gave me theta. Theta's pi over 4. All right, so let's draw that. So pi over 4, the radius is 2. All right, so I know normally if my angle is pi over 4 or 45 degrees, my sides are square root of 2 over 2, square root of 2 over 2, and 1. But my modulus has been multiplied by 2, so my sides for my unit circle will also be multiplied by 2. I don't know know why I flipped that over. So whatever this radius is, we can multiply our side lengths by it. So that allows us to put it in different forms. Like now I can put it in a plus bi form if I want to, because I know that a is the square root of 2 and b is also the square root of 2. So I have square root of 2 plus square root of 2i. If this had been in a different quadrant, like if it had been in 3 over here in quadrant 2, like 3 pi over 4 for my angle measure, my a distance would be negative. So I'd have negative square root of 2 plus square root of 2i. Also, so this is complex number form, but I can also put it in rectangular form. Like I can name this point, it's square root of 2, square root of 2. So I can go from rectangular to polar to complex. Like you can go back and forth between all of those. All right, so we'll talk about that when I see you again and be able to do those things. So we'll practice on that. And then one more thing, I just want to show you this product formula. All right, so a couple of things. There's a product formula and a power formula. So the product formula says if I have two complex numbers that I'm multiplying together, so I just put a little 1 down there, I'm going to put a little 2 down here. When I multiply those together, I'm going to change this letter also, because these may not be the same. I multiply the lengths of the hypotenuse together. So I multiply the radius of the first one and the radius of the second one together. And then I add their angles. So it's cosine theta 1 plus theta 2 plus I forgot the i's in front of those. I sine theta 1 plus theta 2. So that's how I find the product, right? And then there's also a power formula. This is a shortcut if you have repeated multiplication. So if they just say, we want to take this complex number to a power, or this polar form of a number to a power, then I take the radius to a power. So think about this. That would mean these would be the same number, and maybe I would have 3 or 4 of them. So instead of saying r times r times r times r, we would just say r to the third, and then I multiply that number by my angle measure. So it'd be cosine n theta plus I sine n theta. All right, so we'll practice on those when I see you again.